Hello, my name is Tommy, and in today's video I'm going to be showing you the chemical equation for a firework, and I'm going to be showing you how this equation is balanced and how it shows the law of conservation is true. So, since this equation is obviously really big, it has a lot of reactants and a lot of products, I'm going to split this in half to show you how it's balanced. So right here is where it separates into the reactants and the products. So I'm just going to draw a line right here. Then what I'm going to do is I'm going to list out all the elements within both sides. So on this side there's potassium, nitrogen, oxygen, carbon, hydrogen, and sulfur. Now this element or this compound right here is potassium nitrate. This one's charcoal, and then this one's just sulfur. Now in the products we can see that there's 6 potassium nitrate, and so what this means is that there's going to be 6 potassium, so we're going to write 6. There's 6 nitrogen, so there's 6, and then there's 6 times 3, which is 18, so there's 18, but there's another oxygen right here, so we're going to change that. We're going to cross that out and put 19. Then we see that there is 7 carbon, 4 hydrogen, and 2 sulfur. Now we're going to do the same thing on this side. As you can see, there's a lot more compounds on this side, and so what we're going to do is we're going to do the same thing: potassium, nitrogen, oxygen, carbon, hydrogen, and sulfur. Okay, so this compound right here is potassium carbonate. This next one is potassium sulfate, potassium sulfide, carbon dioxide, carbon monoxide, water, and then nitrogen. That is a diatomic element, so that means that it can't be alone, so it's always paired with itself or with another compound. So let's do potassium carbonate first. There is two potassium, so I'm gonna write 2 up here. There's 2 potassium in potassium sulfate, and then there's 2 in potassium sulfide, and that's it for potassium. So there in total there's 6, and I'm just going to cross these out so I don't get confused. And then next is nitrogen. So let's see where all the nitrogens are, and there's only 6 nitrogen right here, so there's 6. Next is oxygen, so we have 3 right here, 4 right here, none right here. We have 8, we have 2, and then we have, oh, I forgot to write 2 here, my bad. So you have 2 here too. So we have 8 plus 4 plus 2 plus 2, that's 16, and then plus 3, that's 19. Next we have carbon. Let me cross out this quickly. So we have 1, we have 4 right here, and then 2. So that's 6, and that's 7. So we have 7 carbon. This is getting messy. All right, now we have hydrogen, and that's pretty simple. There's only water, so that's 4, and then we just have sulfur, and here's 1, here's the other. So there's 2 sulfur. All right. Now that we have every element listed and how many there are and the reactants and products, we can see that this equation is balanced because there's the same number of potassium on each side. There's 6, same number of nitrogen, 6, same number of oxygen, 19, and so on with carbon, same, hydrogen the same, and sulfur the same. So that means that on each side there's a balanced number, and that each side has the same number, and so they're not offset. They don't offset each other, or they do offset each other, but they don't off-put each other. That's what I mean. And if we go into law of conservation, this states that elements can neither be created or destroyed, but they can be rearranged here. Then that's what happens. They do get rearranged. They do change partners within the product, but as you can tell, none of the elements have lost or gained another element. They all stay the same throughout the whole reaction. So this does prove that the law of conservation does work within this equation, because 1, all the elements stay the same throughout the equation. So that was the video. I hope you enjoyed it, and thank you.